Welcome to Variations. In this particular lesson, we are going to look at the concept of proportion. Now, there are two types of proportion. We have direct proportion and indirect or inverse proportion. So for direct proportion, this is where there is a relation between two quantities, that is a constant ratio. In other words, if we have a variable a or quantity a which is directly proportional to a variable b, the relation between these two quantities is a constant ratio. Therefore, if you increase in variable a, you're going to cause an increase in variable b. And if you reduce or decrease variable a, there will be a proportional decrease in variable b. So in short, the increase or decrease is in the same direction for both variables. That is direct proportion. And the steps for calculating direct proportion: number one, simply identify the proportional variables. Identify the variables that are proportional. Identify proportional variables. The step number two, formulate the fractions arising from the initial condition of proportionality. So step number two, you need to formulate fractions. You formulate an equation of two fractions, so the initial condition should result in an equation of two fractions. So we formulate two fractions or an equation of fractions of proportionality. And then after we have formulated the fractions or the equation of the fractions of proportionality, we cross multiply and solve for the missing information. Okay, we cross multiply and solve. Cross multiply and solve. So let's look at a simple example quickly. Let's say there is a contribution that is required from schools, and 20 schools, let's say 20 schools have so far contributed 100,000 kwacha. That's an example. So if we are receiving contributions of equal amounts from schools, and we are able to get from 20 schools we have received 100,000 kwacha. Then how much should we expect to receive from 60 schools? Okay, if from 20 schools we have so far raised 100,000 kwacha, then how much should we expect to raise from Sikiste schools. Okay, so here, if we are to follow these simple steps, we are saying step number 1, we identify the variables that are proportional. So in this case, we are talking about schools, okay, the number of schools against the amounts in kwacha, against the amounts in kwacha. So these are the two variables that are proportional. Now the initial condition is that for 20 schools we have raised 100,000 kwacha. So we want to know how much we'll raise from Sikiste schools. Okay, so we can put the variable x, y, or whatever other variable that is convenient. So we're saying the next step, after identifying the variables, we formulate the fractions and form an equation. So here you can simply say 20 schools over 60 schools. The ratio should be constant with 100,000 kwacha over x. Okay, so that's what we need to simplify, and we are saying in the third step, after forming the fractions on an equation, we cross multiply. So when we cross multiply, we're going to have 20 times x is 20x equals 100,000 times 60, we get 6 million. So solving that equation simply means you divide both sides by the coefficient 20. So when we solve that equation, we're going to find the number of schools when it is increased from 20 to 60. Then the amount that is expected will rise from 2 into 600,000. That should give us 300,000, which means for 60 schools the amount which is expected would be 300,000 kwacha. So you can see that when we increase the number of schools from 20 to 60, we have also experienced an increase from 100,000 kwacha to 300,000 kwacha. You can see that the ratio is constant. The ratio 20 to 60, which is 1 to 3, will be the same with also the ratio of the amounts, 100,000 to 300,000, that is also a 1 to 3. So that's why we're saying direct proportion, you have a relation where the ratio is constant. The variables that are proportional directly will have a constant ratio, right? The other type of proportion is indirect or inverse. So for indirect or inverse, you have two variables that are proportional, right? So we still have two variables that are proportional. Now in this case, for indirect proportional, we highlight it here. For indirect proportion, what will now happen is that when there is an increase in one variable, there will be a decrease in the other. So it's not like direct proportion where when you are recording an increase in one variable, then there will be an increase expected in the other variable. For indirect proportion, it's the reverse, which means when you are increasing in one variable, you are going to decrease in the other variable. Okay, there is going to be a reduction in one while there is an increase in the other. So the steps for solving indirect proportion. Okay, so we are saying that for indirect proportion, if these two variables a and b are indirect proportional, it simply means when we have an increase in variable a, we should expect a decrease or a reduction in variable b. And when there is a reduction in variable a, then there will be an increase in variable b. So what is happening under indirect proportion is the opposite. One variable will be moving in the opposite direction of the other. So the steps that we need to follow, of course, first step, we identify the variables that are indirect proportional. We identify the variables like we saw in direct proportion. Then the second step, like in direct proportion, we generate the fractions. So we formulate the fractions or the equation of the fractions. We formulate these fractions from the initial condition of proportionality. So we study the conditions that have been provided and then generate the fractions from there, like we saw in the example on direct proportion. So now the third step, in the direct proportion, we said we simply cross multiply that equation and then we solve. But for inverse proportion, we first inverse one fraction, which means we multiply by the reciprocal of one fraction. Instead of multiplying by the fraction directly, we multiply by the inverse, or we find the inverse of one fraction. Inverse one of the two fractions. After we inverse one of the two fractions, that's when we can execute the cross multiplication. So in short, for inverse proportion or indirect proportion, there is one more step than we have in direct proportion. So after we inverse, that's when we will now do what? We will do the cross multiplication and solving for the missing information. We cross multiply and solve. So let's look at an example. Let's say we have ten pupils. Let's say we have 10 pupils who have been assigned to sweep a classroom. And they spend 40 minutes to clean the room. Okay, we have 10 pupils that we have sent to clean the room, and they spend 40 minutes. Now, what happens if we increase the number of pupils from 10 to 15? And we assume that these pupils will all be working at the same rate. Then how much time should we expect them to spend cleaning the same room? Okay, how much time will they spend? If we have 10 pupils that are cleaning the room and they spend 40 minutes to do the job, now we decide to increase the number of pupils from 10 to 15. so that they work on the same room. How much time will a group of 15 spend? How much time will they spend to clean the same room? So this is a typical example of indirect proportion, because if the size of the room is still the same, when we increase the number of pupils, it means we should expect that they will do the job quicker than when they are fewer. Okay, so it means by increasing in one quantity in the number of pupils, we are causing a reduction in the amount of time spent. So our solution, following the steps, we are saying step number 1, we identify the variables. So in this case, we can say our variables are the number of pupils and the time in minutes. Okay, the variables in this example are the number of pupils and the time they are spending to sweep the room, according to this example. So there are two variables. We are looking at the number of pupils either reducing or increasing, and the amount of time they are spending to clean the room either increasing or reducing. So the initial condition is that we are starting with 10 pupils who are spending 40 minutes to clean a room. Now, if we increase the number of pupils to 15, then how much time will they spend? So that is the information. So we are saying, according to our steps, we have identified the variables pupils and time. Then we formulate the fractions. So we have a 10 over 15 as a ratio of the pupils, and we have the other fraction, which is 40 over a quantity that we are yet to determine. Okay, now we are saying in the next step we are supposed to inverse one fraction. So if we inverse, for example, 40 over x, the inverse is going to be x over 40, x over 40. So it is this inverse fraction that we are going to multiply with the other fraction. So we have 10 over 15. The constant ratio will be with the inverse fraction, which is x over 40. So here we can now proceed to cross multiply and find the time that the 15 pupils will spend. So here, if we are to multiply, we will get 15 times x, which is 15x, equals 10 times 40, which is 400. So we know that to get our x, it means we need to divide both sides by 15. So the amount of time that 15 pupils will take to clean the same room will be 400 divided by 15. 400 divided by 15. So 400 divided by 15, that should give us about 26 minutes. Okay, 26.7 minutes. So when we increase the number of pupils here, we have increased the number of pupils from 10 to 15. We are going to notice a reduction of the time from 40 minutes to 26 0.7 minutes, which is almost 27 minutes. So that confirms the concept of indirect proportion.